So now that we've had an opportunity to see how BitLocker looks from the user's perspective over on that Windows 8.1 desktop, I think it's also important for us to take a look at how you can configure BitLocker both for data drives as well as operating system drives here inside of Windows Server. You'll see here I'm back on that server file 1 where I want to show you that very different from over in the desktop world, the BitLocker components are a separate installation that come as part of a server feature. So you'll see here that this BitLocker drive encryption is a feature that needs to be enabled on any server that you plan on dealing with BitLocker. I'll just choose next, next, and finish to get through the complete installation of BitLocker. But the one thing I want to tell you as we're going through this, there is, at least with this version of Windows, the version that I'm using here, a little error message that you'll see pop up from time to time that is a reminder you may actually need to reboot the computer twice in order for BitLocker to completely install. So let me go ahead and fast forward things a minute and then accelerate things to the other end of the pair of reboots. So here we are back on file 1, and I want to show you that just like over the desktop side, if we go here to our BitLocker control panel, we can now take a look at actually configuring BitLocker for either our C drive, our OS drive, or down here for our data drive, the E drive, where our company share is located. If I go ahead and close this, I also want to show you that, coming down here to PowerShell, there is actually a command here that you can use to initialize and make use of the TPM chip that happens to be on a system. That command is initialize TPM. Now here you'll notice that because we don't have a TPM chip on this computer, we're not going to be able to use that command. And so I've also come down here to our local group policy and configured here under Windows Components, BitLocker Drive Encryption, and then Operating System Drives, the additional item here called Require Additional Authentication at Startup. So we saw this just a second ago as a mechanism to turn off that TPM requirement. Now here inside of Windows PowerShell, however, is where we want to take a look at just some of the things that we can do, the extended series of commands that we can use in order to just see what sorts of BitLocker volumes we have, to turn it on for example, our data drive here on this machine, to add the appropriate password protectors that we may require, so making sure that we have the right kinds of protectors for these drives. And then also a little later on, go through that process of ensuring that the keys, those recovery keys, are backed up into Active Directory so that we could potentially later recover them from Active Directory should we lose our keys and are unable to decrypt the drive. So let's take a look at just a couple of commands here. The first one is get BitLocker volume, which gets us, as you can see here, not that much because it's just showing us we have no BitLocker encrypted drives here on this machine at this point. But this command still is kind of useful because it helps us understand as we go through the encryption process where we stand in that encryption process. The process can take an extended period of time. It also, over here on the right, can show us which of the key protectors have been enabled for that specific drive. Now, we've already talked about those key protectors and the different kinds that exist. What's important to recognize is that you can use different key protectors for different drives. So I could turn on an Active Directory group for one drive, but only use a password on another. I could turn on TPMs for one drive, but only use something else entirely for the data drives on this machine. Let's go through now and enable BitLocker just on the data drive, this E drive over here on the computer. Now, this drive is a terabyte in size, so 1.023 gigabytes in size. So whereas you might not necessarily do this in production, the actual contents of this drive are quite a bit smaller. So I want to make use of this enable BitLocker functionality, but I only want it to encrypt the existing used space only. I can do that with enable BitLocker, and then the drive I'm interested in, which is the E drive. And then for my next parameter here, I want to identify which of the protectors I want to use for enabling BitLocker on this drive. And there are just 5 or 6 or so different combinations you can use. In this case, let's choose just the password protector. This means that if I have the right password, I'll be able to decrypt the drive. I also want to set to encrypt only the used space on that drive, just simply to speed up the process of doing the encryption. Now, when you invoke this, if I hit the Enter key here, you'll have to punch in the password that you'll use to encrypt the drive. I'll punch that in there, and I'll punch it in a second time to confirm the password. Once that's done, encryption begins on that E drive. And if I go back, you'll see, actually, you can see the little window that appears here inside the graphical user interface. But if I come back and choose to view the BitLocker volume again, let me clear things here to make it easier to see. It's here where we can see what percentage in progress we are with encrypting that very large drive. You can also see that we've now assigned a key protector here, the password protector, on this E drive. So we now have a proto-encrypted drive that's going through its process of getting all this content encrypted. This process, as I said, can take an extended period of time, and so you might want to set this aside for some time in the evening, for example, sometime when people aren't making use of the system, because the amount of CPU resources that are required to complete the encryption can be fairly significant. While this drive is going through its encryption, I want to show you just a couple of the other key protectors and the specific parameters that are used to identify when you want to add those key protectors. Once I have a drive that's been encrypted or is being encrypted that has an existing key protector associated with it, I can use another command here called add BitLocker key protector as a mechanism to add an additional key protector over the top of the one that already exists here on the drive. Now, what I want to show you here is that if I do help on this, this will give me the list of the different kinds of key protectors that exist. And if I hit to maximize this, I can kind of scroll over just a bit just to show you that these same protectors that you saw me reference in that parameter just a second ago are represented here. So our password protector, our recovery password protector, which we'll talk about here in just a second. The startup key protector, if I had that separate USB key. And then down here, if I had the TPM, I could use the TPM and startup key protector. Also, here's the AD account or group protector if I wanted to associate an Active Directory group with the encryption on this drive. So let's now use this to, even while this machine is going about doing its encryption, adding in an additional key protector that's an Active Directory group. This will allow the members of that group to also have the privileges to decrypt the drive. Let me clear the screen here, and if I can get my screen back over here, let me clear the screen here, and let's do that add BitLocker key protector on the E drive again, using this time the AD account or group protector, with the AD account or group being company, domain, admins. And I could also use the /service switch if I wanted to set this up as a service, but I'll just set this up like this, so the domain admins is now added as that second protector here for the E drive. You'll see that now, over here in the list of key protectors, I have password and AD account or group. So these are now two different mechanisms that can be used to decrypt this drive. Now, as I mentioned earlier, one of the great use cases for BitLocker is perhaps not necessarily full drive encrypting your data drive here for this file server that's protected inside your data center, but useful for those other computers that maybe don't have the same level of physical security that those do inside your data center. Let me flip back over here to RODC1. So an RODC makes a perfect use case for drive encryption because the whole point behind an RODC is that it's intended to be a smaller, if you will, version of Active Directory that protects you from the loss of that not quite physically secured computer. Well, for that machine, we can use BitLocker to provide an additional layer of security by simply encrypting the entire C drive on this computer. And I'll show you that the process here is pretty much the same thing. In fact, the one command I need to show you here is the enable BitLocker command, which we've already seen. And if we do the C drive here as opposed to the E drive and our password protector and even the used spaced only command here, the one thing you'll notice after I punch in my password and then confirm my password here is that in order for this to function, we actually have to go through a computer restart. Now, this computer restart is designed to allow BitLocker to perform some hardware tests. So my last step in this process will be to restart the computer here and then allow it to continue encrypting that drive. So let me go ahead and do that here, and in the next clip coming up, we'll talk more about the BitLocker policies that you can lay into place using group policy while we wait for these different drives to complete their encrypting.